Now we will exercise with Louisville Formula. Louisville Formula, and so we will recall something. So last year in the spring semester, at the very end of the spring semester, we tried to solve something using Louisville's formula. So it is difficult to remind, but this is true. And now we will try to. So we will exercise with Louisville formula, and maybe the end of the last semester will help you. It's seminar number 6. So Louisville formula. And variation of parameters. And I'd like to start with the method of variation of parameters for solving linear differential equations, not non-homogeneous differential equations. Okay, we will start with the variation of parameters. This method was discussed in the preceding semester, so I'd like to recall this method. For example, suppose we want to solve this differential equation. Second of x. Kathy likes seconds, right? Second, what is it? Second. 1 over cos x, right? 1 over cos x. Let's try to solve this differential equation by the method of variation of parameters. Well, so the first step is to solve a linear homogeneous differential equation. Well, how to solve it? So we should write down the characteristic equation. Plus lambda equals 0. Then the roots is lambda 1 equals 0, lambda 2 equals negative, so I. Negative I, so 3 roots. And then the general solution to this equation will be y is equal to, do you remember, c1 times e to the power 0t. Or x, let it be, sorry? I and minus I, because, so it can be, so if we factorize this, we will get lambda squared plus 1 equals 0. So 0 and the roots of this quadratic equation, they are I and minus I.
So I multiplied by minus I gives us a 1.
Right, yes. So I multiplied by minus I gives 1, right. Well. Okay, so 0x plus then c2 and then e to the power ix, but we should replace this by some real solution. Right. So if we have, so the rule is, I will use this part of the blackboard. If a root of the characteristic equation is a plus ib, then this root corresponds to the linear combination, to the solution of the differential equation having the form e to the power ax times c1 cos bx plus c2 sine bx. not complex solutions, but real solutions. We need real solutions. So we should remove this. So this is not correct. So it must be cos x plus C2 sine x. But this is e to the power 0x is just 1. So this can be replaced by C1. So this is a solution to the homogeneous equation. Okay, step number 2. Now I'd like to solve the non-homogeneous equation. But if we have a quasi-polynomial in the right-hand part, so if we have some expression involving linear combination and products of e to the power, so a combination of e to the power lambda x, cos alpha x, sine beta x, some polynomials, it is called a quasi-polynomial, then we can use the method of undetermined coefficients. It is more efficient for the right-hand side, for the function in the right-hand side of the, which is represented as a linear combination or product of these components, of these factors, of these terms. But for the general, but our right-hand side is not of this form, 1 divided by cos x, not multiplied, but divided by cos x. This is not a quasi-polynomial, and so we can't use the method of undetermined coefficients. And so we will use the method of variation of parameters. In the case of this right-hand side, it is less efficient, but it is more powerful. This method is more powerful because it is applicable for any function in the right-hand side, not exactly the quasi-polynomial, but any function, right? It can be applied to any function. Okay. So now we will use the method of variation of parameters. And as it was described in the spring semester, the method is the following. So we assume that C1, C2, and C3 are not constants, but they are functions depending on x. So y is C1 of x plus C2 of x cos x plus C3 of x sine x. And we are trying to substitute this function into this equation. And some manipulations, they were discussed in spring, but so now I will state the result. As a result, we need to solve the following system of differential equations. So first, the derivatives of these 3 functions multiplied by the functions 1 cos x and sine x. So I mean this, C2 prime times cos x plus C3 prime times sine x is equated to 0. Next, C1 multiplied by the derivatives of these 3 functions. The derivative of 1 is 0. C2 prime times the derivative of cos x is minus sine x plus C3 prime times cos x equals 0. So cos x is the derivative of sine x. And the last equation will be C1 prime times the derivative of 0 is 0. C2 prime times minus cos x minus C3 prime times sine x equals not 0, but 1 over cos x. So the next step is to solve this linear equation. So this is the system of linear equations in variables c1 prime, c2 prime, and c3 prime. So these three coefficients can be found from this linear system, and after this we will we will find c1 prime, for example, as a function of f of x, and next to find, so let it be I, and to find ci we should integrate, find the integral. Okay, so the first step is to solve this. So it is not difficult to solve. First of all, we can notice that this is 0 and this is 0, and this can be removed. These two terms can be removed. And after this, we are trying to solve this linear system. I will rewrite it in the form minus c2 prime sine x plus c3 prime cos x equals 0 minus c2 prime cos x minus c3 prime sine x equals 1 over cos x. And I want to solve it. Okay, to eliminate, I want to eliminate, maybe let's eliminate c3 prime. To eliminate c3 prime, we will multiply the first equation by sine x and the second one by cos x and add them together. Then c3 will be eliminated, and we will get the following: minus c2 prime sine squared x minus c2 prime cos squared x equals 1, from which we have minus c2 prime equals 1. So c2 prime equals -1, and c2 equals the integral of -1. The integral is minus x. Minus x plus c2 bar. Well, so the next I want to eliminate c2. To eliminate c2, I will multiply the first equation by cos x and the second one by minus sine x. And as a result, I will get c3 prime equals minus sine x over cos x. Now my goal is to find c3 as an integral minus sine x over cos x dx. Sorry? The tangent, right? It is, but we should integrate it. Is d of cos x over cos x. And so it is the logarithm, natural logarithm of cos x plus c3 bar tilde. This is the answer for c3. And now our goal is to find c1. We need c1. We know, so I will rewrite the equation for finding c1 prime. Okay, c1 prime plus c2 prime, which is -1, so minus cos x, and c3 prime is minus sine x over cos x, so minus sine squared x over cos x equals 0. Therefore, c1 prime is equal to cos x plus sine squared x over cos x equals 1 over cos x. And next, let's find C1. How to integrate this? The integral dx over cos x. Do you know how to find this integral? Do you remember? What shall we do to find this? Who knows how to integrate dx over cos x?
Full of bits. Please, this is for 1 point for the final integration.
Well, so multiply and divide by cos x. And then rewrite it as d sine x over 1 minus sine squared x. And then, so the table of integration table of integrals.
Can we use the table of integrals in the exam?
No, so you should memorize it. Right, so it is like the x over x squared minus a squared. What is the answer? Logarithm, right, 1 over 2a. Correct. And so the answer is we should change the sign, minus 1 over 2, the logarithm of sine x minus 1 over sine x plus 1 plus c1 tilde. Well, and after this I will substitute these values into our solution. So answer y equals c1 multiplied by 1. So c1 minus 1/2 the logarithm of sine x minus 1 sine x plus 1 plus c1 tilde. Next, c2 can be taken from where is c2? C2 is this, minus x multiplied minus x cos x. Minus x cos x plus c2 tilde cos x. And plus c3 sine x. C3 sine x. Now c1 tilde, c2 tilde, and c3 tilde are constants. And this is the answer to our task. The solution again. So the plan. Shall I explain the plan first?
Yeah.
The plan. So the first step is to solve homogeneous differential equation as usual. First solve the characteristic equation, find the roots. So find the general solution to this homogeneous equation. Okay, is it clear? Rohan, is it clear? What about telephone in your hands? Well, step number 2. So we assume that, we will look for the general solution of a non-homogeneous equation in this form. So we will assume that our solution has this form, but C1, C2, and C3 are not constants, but they are functions depending on x. Okay, we are trying to substitute y into this equation, and this will lead us to this system of linear equations in variables C1 prime, C2 prime, C3 prime. So it was explained in spring last year, so I don't want to repeat it. So maybe this is the rule and you should memorize it, right? So how to obtain this linear system? We take the derivatives of the functions C1, C2, and C3 and multiplying them, okay, step by step. We must multiply them first by the functions 1 cos x and sin x, by these functions, and equate to 0. Next, multiply them to the derivatives of these three functions and equate to 0. And after all, we multiply C1 prime, C2 prime, and C3 prime by the second derivatives of these functions. So first derivative, second derivative, third. So the function first derivative, second derivative. The function first derivative, second derivative. Function first derivative, second derivative. And the last equation is equated to the right-hand part of our differential equation. Okay, is it clear? So the plan. It is the plan.
Do we have three equations in the system because of y and 3 primes?
Yes, yes. So if we have the third order equation, then we have system of three equations. If this is the second order equation, we will have the system of two equations in two variables, right? Of course, the number of equations and the number of variables coincides with the order of the differential of the original differential equation. And next, we are trying to solve this linear system first. So we will try to find the functions. Try to find C1 prime, C2 prime, and C3 prime from this linear system. Okay. So I have noticed that these two terms are 0, and so I'm trying to solve this part of the linear system. Two simultaneous equations, these. And to eliminate C3, I multiply equations by sin x cos x, right? And so I have found the formula for C2 prime. It is -1, and so C2 is this. Next, I found the formula for C3 prime and found C3 then just to integrate this. Okay, plus C3 tilde. And after all, I need to know C1 prime. Then I have substituted the formulas for C2 prime and C3 prime in this first equation and found the formula for C1 prime and integrate. So, right, this is the formula for C1 prime. It is 1 over cos x. And after this, I have integrated and found C1. This is the formula for C1, and the answer is obtained by substituting these functions for C1 of x, C2 of x, and C3 of x in this formula. Clear? Okay. Well, let's continue. The second order equation. Task number 2, let's solve this. y2 primes minus 2y prime plus y equals e to x over x. And solve this using the method of variation of parameters. Who wants to solve? Follow, welcome. same, I think.
Yeah, I think it's
The
one
same.
twice.
One. Twice, yes. This is a multiple root. Next, we shall write the general solution to the homogeneous equation. Or x. So now our variable is x, so e to x. No, so it's y. Why? So sometimes we use the letters t for independent variable and x for a function, or we may use x for an independent variable and y for a function. So this is the case now. Right. Right. Then you should do what? Multiply by x, right? C1 times e to x. E to x. C2, x, e to x, and remove add to e to x, or not this. So multiplied by and e to x, or you can write it in the form c1 plus c to x.
Yes.
Two ways to write the answer. But now we need these functions. We will take and differentiate these functions. Okay, so step number 2.
So, and the reason we can't use this is because we don't have any of
Right.
Okay.
So for this function, we need to apply the method of variation of parameters. So now we assume that C1 and C2 are two functions depending on x.
So first we
C1 prime, right? Not not differentiate now. So multiplied by the functions, exactly the functions, not derivatives of this function, times x e to x equals 0. This is the first equation. And in the second equation, you should differentiate these functions, the same e to x, and you should replace the second function by its derivative. Correct. Equals the right hand side, right? Next, try to solve this.
just subtract from each other.
Subtract, right? Because he needs space.
Should I continue here?
Yes, sure. Correct. Right. But the derivative of x is 1. The derivative of x is 1. Let's replace it. So remove this. Well, so now this is correct. ln x. Oh, so not this answer, but you should substitute the derivative 1 over x. Look at the equation. So x c2 prime, not c2, but c2 prime, replaced by x or by 1 over x. -1. Right. Correct. Thank you. Okay. Well, okay. Shall we have a? We may have a break now, and next we will continue, because next we will discuss Louisville formula. I don't want to start to discuss it. Maybe after the break. Let's have a break. Well, let's try to use the Louisville's formula. Well, now task number 3. First of all, so what is Louisville's formula? So we need to recall the Louisville's formula before we discuss task number 3. It is for the homogeneous differential equation, a depending of t times x. We consider this differential equation. We consider the fundamental solution. It's a fundamental solution. So this is the matrix consisting of the vectors. So the matrix whose columns form the basis in the solution space of this differential equation, right? And Louisville's formula tells that the Wronskian of this fundamental solution is equal to the Wronskian which is found at some value t0. So t0 is fixed. So we may find that. So if we know this matrix, we may find the Wronskian of this fundamental solution at the time t0, right? Multiplied by e to the power the integral from t0 to t. Next, what is the function? We need to integrate which function? Which function shall we integrate? the trace of this matrix A of S ds. Well, how can we use this Louisville formula to solve for solving the following differential equation? So task number 3, we want to solve the following: x y2 primes minus 1 plus x is y prime plus 2 times 1 minus xy equals 9x squared e to the power 2x. X is greater than 0. So we want to solve this differential equation. I will check the coefficients. Okay, this differential equation is linear in y and its derivatives, right? It is linear, but with non-constant coefficients. So we can't apply this method. So this is the method of characteristic equation can be applied for differential equations, linear differential equations with constant coefficients. So it is important that the coefficients are constants, not the functions, but they are constants. And in this case, we can write the characteristic equation, solve it, and represent the answer in this form. But if not, for example, in this case, so you can see that the coefficients are not constants, they are functions depending on x. X minus 1 plus x, 2 multiplied by this. So we can't apply these formulas, but we want to solve. How to solve? And how can we apply this Louisville's formula? Okay, I state that if we know, okay, step number 1 is to find one solution. So we can guess one solution. And the second solution can be found using the Louisville's formula. So first, and step number 1, we start with homogeneous equation, of course. So next, after this, we will solve non-homogeneous equation using the method of variation of parameters. But first, we start with the equation, with this equation. And first task is to guess the answer, some function, one function. We need to guess one function. Let's try the function of the form y equals e to the power ax, where a is a constant. I will try to find the constant a. As before, as in the situation of the equation with constant coefficients, so we know that usually the answers can be represented in this form, but maybe in our case this is also a solution. Let's try to substitute this function into our equation. And so we need to find y prime, it is equal to a e to ax. Y2 primes will be a squared e to ax. And next substitute them into our equation, and we will get x a squared e to ax minus 1 plus x times a e to ax plus 2 1 minus x e to ax equals 0. We can divide by e to ax, and we will get xa squared minus 1 plus x a plus 2 minus 2x equals 0. Okay, so we should open the brackets and regroup this. X multiplied by a squared minus a minus 2 and minus, so plus 2 minus a must be equal to 0. And if a is 2, then this coefficient is 0, and also this coefficient is also 0. So a equals 2 is a solution. And we can see that the function y1, which is equal to e to the power 2x, is a solution.
Different to random thing to
So the form. You're asking about the form for the for a particular solution. Usually you should try e to the power ax or the polynomial or x raised to some power n maybe.
how can I know what should I use to get an answer?
Okay, so you should use patterns of the form e to the power ax or polynomials. So there are two variants. For and you will get, if you substitute x to n into this, you will get the equation for finding n. Maybe we may try this function, but I think it will not lead us to the answer. But you may try this, or you may try trigonometric functions sometimes. So the same functions as in the case of constant coefficients. So try these functions. Well, but now we know that this is a solution. And after this, we will try to use the Louisville's formula. But if we compare our equation with this system, with this linear differential equation, we can see that they're different, right? We have one second order equation, and we have a system of linear equations in that case. What is trace of A? What is trace of A? What is A in this case? What is Wronskian? Okay. So to answer these questions, we can rewrite this equation in the vector form. So in our case, we will introduce new variables. It will be y1, which is equal to y, and y2, which is equal to y prime. And our differential equation goes to the system of differential equations of the form so y1 prime equals y2, and y2 prime is can be found from this equation. y2 prime is equal to y double prime. So we should solve this for y double prime, and we will get the following: 1 plus x over x times y1 minus or plus 2x minus 1 by x. So y prime is y2, I think. It's y2, y1. Okay, is it clear? So the first step is to rewrite this equation as a system of two linear differential equations.
So what you're saying that when choosing another, but EAX, if we choose the wrong, say if we choose XN, then there can be a chance I'll never get to a solution. I'll just be stuck.
Right. So so the equation for finding A or N should be easy. If they are not easy, then you should try another function. Well, if we rewrite our equation in this form, then we can see that the Wronskian will be y1, y1 prime, y2, y2 prime, and the matrix A will be, so the matrix A can be taken from here. It is 0, 1, 2 times x minus 1 over x, and 1 plus x over x. And the trace of A is equal to, so the trace is the sum of the diagonal entries. It is 1 plus x over x. And in general, so generally, so this is particular case, we have treated this particular case. But generally, how to apply this formula for n first order equations to the nth order differential equation, how it can be applied generally. So we need not do, we need not rewrite our equation in this form each time. So I'd like to show you how to extract the answer from this equation generally. What shall we do? I will use that space. So generally, if we have something like an y to the power n plus an minus 1 y to the power n minus 1, so an minus 1 can be functions, not the constants, right? Then, as before, we can, if we introduce new variables, we can rewrite our equation in the form y2 prime equals y1, y3 prime equals y2. So, no. y1 prime equals y2, right? y2 primes equal y3, right? yn prime equals minus an minus 1 over an yn minus dot dot dot. As before, it was discussed on the preceding seminars. I think it's clear. Now, what is matrix A? Matrix A now is 0, 1, dot dot dot, 0, 1, and zeros. So zeros on the main diagonal, and the last entry will be minus an minus 1 over an. What is the trace of this matrix? What is the trace of this matrix? So this is the trace, because we have zeros on the main diagonal. So this is the trace. The last element, right? And you can see that we can extract the trace from this equation. So minus an minus 1 over an. But I need not rewrite this equation as a linear system each time. We can memorize that the trace of the matrix A is the negative of the ratio of this coefficient and this coefficient, right? So we should take this coefficient, divide by this, and put minus. So the negative of this. Well, so this is the trace of our matrix, and look here, let's apply this rule. So we should divide this coefficient by x and change the sign, right? And we will get this 1 plus x over x. This is the trace.
How can I find the trace without doing that?
Of this matrix? So the trace is the sum of the diagonal entries.
But you can get the trace from the equation itself, right?
Right. So without writing this system and this matrix each time, we can extract the trace from this equation itself, of course. So I see it. I understand. So we should consider these two coefficients: the coefficient of the s derivative of y and the n minus 1 derivative of y, right? So take these two entries, divide this coefficient by this coefficient, and change the sign. So we will get the trace. We will get the trace, and we can apply the Louisville's rule, Louisville's formula. So this will be a constant, right? Because so I don't know what is this. So it is for fixed t0. So I will replace this by the constant. The Wronskian is this determinant. So let's apply this formula in our case. So the Wronskian will be y1 prime. So I know that y1 is e to 2x, so e to 2x and the derivative of y prime, so of y1. So this is the first column. In our case, it has this form. Then y2, we're looking for y2, and the derivative y2 prime equals the constant times e, so this is the constant, times e raised to this power. Then so the integral of 1 plus x over x dx. Indefinite, we can use indefinite integral. Well, let's find the answer. So I need to find the integral 1 plus x over x dx. It will be the logarithm of absolute value of x plus x, and plus the constant, but the constant goes here. Well, so from this equation I have the following: e to 2x times y2 prime minus 2y2 equals c times e to the power ln x. I will omit the absolute value because x is positive. We're given that x is positive. So plus x. Well, and from this we have, this is the same as, so I will use that part of the blackboard. Have the following: e to 2x times y2 prime minus 2y2 equals c times x plus e to 2x Okay, and now I want to find y2. So if I divide by e to 2x, I will get the equation y2 prime minus 2y2 equals cx e to negative 2x plus c e to negative x. Well, and so let's try to solve this. Let's try to solve this equation. So it has constant coefficients, and it has the right-hand side as a polynomial right-hand side. Okay, so first we solve this equals 0 from the characteristic equation, and the answer will be y2 equals c2 e to 2x. And next we need a particular solution to this equation. A particular solution will be y2 A particular solution will be found in the form a x plus b times e to the power minus 2x plus c e to negative x. Well, prime equals a minus 2ax minus 2b times e to negative 2x minus c e to negative x. And then I will substitute it here. And I will get the following: a minus 2ax minus 2b e to negative 2x. Okay, c is not good. Let it be d. Well, minus d e to negative x minus 2y2 e to negative 2x minus 2d e to negative x, and it must be equal to this expression. Well, okay. So a minus 2ax minus 2b times e to negative 2x equals to minus ax plus b e to negative 2x equals Then from this we have the following. Minus 2b minus 4b minus 4ax equals ex e to negative 2x. Okay, so we have divided by e to negative 2x, and so we have that 4a equals minus c, so a is minus c over 4, and b is equal to minus c, right? And here, so just a moment. So just a moment, and I'll have a look. This it's too complicated, I think. Well. Well, yes, but I think maybe it would be easy to yes, but we need to solve this, but maybe it's better to use the integrating factor here. Just a moment. Yes, maybe it's better to use the integrating factor. So if we want to solve something like y2 prime minus 2y2 equals c times x plus e to x e to negative 2x. Maybe instead of this, it's better to find the integrating factor a of x, which is equal to e to the integral of negative 2 dx. So e to negative 2x. I will try to use the integrating factor. Maybe it would be better. Maybe it would be faster than solve it in this way. So the integrating factor means that if we multiply our equation by this factor, it would be e to negative 2x y2 prime minus 2 e to negative 2x y2 equals c e to negative 4x x plus e to x. Then it is e to negative 2x y2 prime equals c e to negative 4x x plus e to x. And then to find this, we need to integrate. E to negative 2x y2 is equal to the integral c e to negative 4x x plus e to x dx. But now we need to find this integral. I think we need to integrate by parts. We will use the integration by parts. The integral of c e to negative 3x dx is minus c third e to negative 3x plus c1. And the integral of cx e to negative 4x dx. Using integration by parts, it is equal to the integral of c x d e to negative 4x. It is equal to minus c fourth x e to negative 4x minus the integral of e to negative 4x dx. For x plus 1 over 4 e to negative 4x. So now we're very close to answer. So we have found this product. It is the sum of these two integrals plus the 2. And so from this, y2 is equal to, so we need to multiply this by e to 2x, and we will get the following: minus c third e to negative x. Next, minus c fourth x e to negative 2x minus c over 16 e to negative 2x plus plus the constant c1, let it be c1, or let it be c1 here, c1 here, and c2 multiplied by e to 2x. Well, so this is the solution to the homogeneous equation, and the last step is to find the solution to the non-homogeneous equation. No. Yes, I see that it is. I think it's too complicated. All right. Right. So this is not only y2, but since it involves um, it involves two constants, then this is the general equation to our homogeneous, the general solution to our homogeneous equation. So I don't know what to do with this. I see that it is too complicated. I think the Louisville formula is too difficult, right? Maybe we will.
What is the steps exactly?
Right. I wanted to show you how to find the Louisville formula, but I see that it is too complicated maybe for you, right, to form so many steps, right? So first step is to guess a solution, and the next step is to find y2 using Louisville's formula. And after this, the last step must be to find the solution of the general equation using the method of undetermined coefficients. Method of undetermined coefficients applied to this equation. I think it's unreal, right? So we need to think of these coefficients as functions and try to find them. But maybe it's too difficult, I think. Well, I think we should stop here. So, right. So the homework will be to apply maybe the method of undetermined coefficients only, not Louisville's formula.
I have a question. Right. When will we have the midterm control work?
Right, we will have it, I think, so it must be, I think, at the end of the October, so in 2 weeks, I think we should have it. No, so I will not do it.
Thank you.
But the method of undetermined coefficients will be.